Hello, everyone. I'm Vadim Supitskiy. I'm head of engineering at Forbes. I'm responsible for our development, our QA, our DevOps and data products, and I've been with the company for 11 years.
Hi, my name is William, Director of Engineering at Forbes. I lead the team of application engineers under Vadim.
And today we're going to take you on a journey of our cloud migration, our road to the cloud. We'll talk about our mistakes, what we learned, our challenges, and benefits. So hope you enjoy the journey.
Yeah, so let's start by talking a little bit about why we moved to the cloud. So there are three key areas that drove us to move from previously being on-prem with the data center into a cloud-based solution, particularly in this case with GCP: velocity, abstraction, and stability. For velocity, we of course wanted to increase our speed to market, delivering more features to users so that they could read Forbes.com in the most efficient way, and being able to target more efficiently. CI/CD, a major part of course of velocity, making sure that we could automate our entire flow as we go along. And then those both tie into having a very fluid software development lifecycle. Abstraction was also massive for us in choosing which cloud to move with. GCP and a lot of the managed services made it very easy for engineers without ops backgrounds or traditional server-side backgrounds to jump right into building applications and getting that to work. And also removed our infrastructure concerns. Of course, coming from a data center and having physical servers, that was a whole other level to worry about as well. And then stability. Of course, being able to leverage managed Kubernetes instances and more led to scalability, availability, and disaster recoverability. Yeah.
Yeah, speed and automation is a forefront for us everywhere, and obviously in technology too.
Yeah, so let's talk a little bit about the lift, what we actually had to move going from our previous infrastructure onto our new Google Cloud-based solution. So Forbes.com, it is a website, but the site when you visit it is actually a bit over 50 different services for the architecture that we have in place. And those span across the front ends that you see, sometimes with different services for different templates, depending on how they're served and the level of traffic they have, as well as multiple content management systems, as well as ETL pipelines.
So we're not microservice architecture, but we service architecture. Some are micro, some are not so micro, but yeah.
Most are not so micro. Yeah.
Yes. And here's our kind of architecture diagram prior to our migration. I couldn't fit all 50 services here, but this is kind of abstraction that I'm going to walk you through. We have had two CDNs, Fastly and Akamai. We had F5 load balancer, which basically load balanced where to push the user to, either to our dynamic templates, which would go to Varnish, as you can see there. And Varnish is our caching layer, which we put in front of templates. At the same time, templates talk to API to get the data, so API is in the heart of our system. If not, then the F5 load balancer would push the user or the data requests to Apaches, which would serve all the static content, static HTML. We have that, all the JavaScripts, all the CSS files would go through that. We also had a different branch here specifically for our DAM, digital asset management system, which included Tumblr, open source software, which resized and compressed our images. That then went to Akamai, which cached, and again, another Varnish layer, and our DAM API. For ETL, we use ActiveMQ and MuleSoft, which would process all our messages, all our data, and insert it in on-prem MySQL and MongoDBs. We also had some things in AWS, our AI skills. We moved to AWS as a first step kind of a long time ago, and they're crucial to our CMS, so we had that there. And in a nutshell, this is kind of our architecture prior to migration.
Yeah, and then looking at this as well, as Vadim said, this is highly abbreviated and abstracted. So there we actually have templates and API, as if those are like insignificant kind of parts. But there's multiple template engines, multiple APIs that are powering all of this. And that's where our core of our application logic lives within the larger abstracted architecture. Yeah, so moving to the cloud, there were challenges. If any of you have done it or attempted to, I'm sure you're aware of that as well. So in one set of those in particular was organizational challenges. We were in a very fortunate situation at Forbes where we were actually able to make the decision and already had C-suite buy-in to invest in moving from on-prem into the cloud. And we're also trusted within our own organization to make decisions such as let's move to GCP, and that's the best solution for us. But we still need to get team buy-in, and when I say team buy-in, I also mean like fellow engineers, DevOps professionals, networking and security teams, and making sure that we're actually all aligned with moving forward for that vision, and that we all believe that it was the right set of tools and technologies for us to work with. Another big thing for us too was also picking a consulting partner. We hadn't migrated certainly nothing of this scale to the cloud before, and expertise in GCP was something we were still developing very much so in-house. So we wanted someone who had experience doing that multiple times to guide us along the way and vet our decisions as we went along. And finally, of course, picking technology partners. For that, GCP is one of them, as is Google, but I also mean solutions such as how are we going to handle monitoring, how are we going to handle password secret storage, and other additional choices along the way.
Yeah, and what is managed for us, what would we have to kind of build our own. So a lot of decisions, obviously, prior to moving to the cloud, and a lot of challenges, as we'll show you more in these slides. So I want to touch base on the migration timeline and how did we approach each step. So first step, decide on a cloud provider. Obviously was critical for us. We tried and did prototypes with three of the big players, obviously Azure, AWS, and Google. We did kind of small applications that we migrated. We showed them to our engineers, DevOps, and based on the feedback and just the ease with which they migrated those applications and how did they like working with the platform, and just overall kind of cost obviously was part of it, and a lot of different components there. We at the end decided to go with Google, and so far very happy with the decision. Next step was picking the actual partner that will help us migrate. And again, same approach. We did 2-week proof of concepts with each of the partners. We had 3 that we picked. And the one that we felt comfortable with, the team felt comfortable with, the one that provided us the best kind of plan forward, the best timeline for our migration, we picked that one and we started to move forward. Next step for us was critical, and absolutely, if you planning to migrate, I think this is something you have to do. It's kind of discovering, again, your systems, going through inventory of each server that you have, each network that you have set up. How do applications talk to each other? Where do you have load balancing set up? Where's the caching? And where's the security set up? Like what can talk to each other, what can't? This was so critical for us that without this, I don't think we would have been successful.
And not only that too, Forbes is a 100-year-old company as well, and we've had a web presence since there was, well, like a web. So particularly for companies with a history of that nature too, I think you're going to find a lot of skeletons in your closet along the way, or systems you didn't even know were running that are going to have to be accounted for.
Yeah, we definitely found legacy server somewhere in the closet along the way, so
a literal one, yeah.
And so doing that step, it helped us a lot in onboarding the partner, right? Now we had new kind of diagrams, updated diagrams and architecture kind of plans of how everything works, so we could actually walk our partners through it and show them how everything is set up. So our kind of onboarding of our partner was made a lot easier by us doing that prep work prior. So next step was planning the architecture and figuring out how it's going to look in the cloud. So we have our architecture in on-prem, and then how do we move it to the cloud? And that went through a lot of different iterations, to be honest, and until we were happy with it. So that was a step that was also critical for us. Then the kickoff, which was very exciting. We wanted to move forward as soon as possible, and we started migrating. At some point, obviously, we realized that we should do things different. So that took some time for us to get comfortable. But we were very happy to get everything first to development project, and then move everything to staging, and then start moving to production. Our approach was to move to production in phases, and it was a good approach, and mostly we were doing it that way, but there were a couple of gotchas. We realized that our core applications had to be moved together. And the reason for that is that when you have your core applications, some of them in the cloud and some in the data center, we quickly realized there is latency in that communication. So we had to make sure that our database, our APIs, and templates that talk to it had to be moved at once. And then everything else we could kind of stagger along and migrate as we went through. We also obviously tested it very well on staging, load tested. That's very important. Try to simulate production traffic. It's not easy, but do as much as you can. Obviously, when you move to production, there are going to be some gotchas. I'll actually share one. We have a lot of traffic to our site. And what happened to us is that there is a limit set on kubedns to 150 concurrent connections. And we realized that after we started migrating. So thankfully, we were able to change that, but that was definitely something that we did not expect. And yeah, moving to staging, moving to production, we had to make sure that we had a plan and had something really automated set up where we can go from dev to staging to production with a click of a button. Next, one of the first architectural decisions that we had was how do we set up our projects? And we had a couple of schools of thought there. One was we have 50 projects, 50 applications. Why don't we set up 50 different projects? We quickly realized that was difficult for us, and from security standpoint was not manageable because now the same developers, the same person will have access to both production, development, and staging application. Which obviously is not acceptable. The second school of thought was, well, then why don't we just create one big project and have all the applications there? Again, makes the management extremely easy, but concerns, again, security concerns, again, that developer will have access to everything, so we could not allow that. So the way that we structured our projects was something in the middle. 3 projects, 1 for development and staging, 1 for production, and 1 for our management tools. So something like Jira, Confluence, Vault, we would keep in our management projects separately for security reasons and overall for easier management. Yeah, so that's how we decided to approach our project architecture.
Yeah, so let's talk a little bit about how we actually broke up the clusters inside of those, which that diagram already began to allude to a little bit. So in terms of choosing what really lived beside other applications on like a cluster level, now that we already had projects defined, we broke it up into kind of 6 main categories. Forbes.com, which was our varnish caching layer, all of our templates applications, and our APIs. As Vadim said, having those live alongside of each other was absolutely necessary, especially once we started to realize the latency that was introduced between communicating with GCP back to our data center compared to how fast that could be if everything was just side by side. The other one is our ETL pipelines and tools related to that. We name it Mules, but it's ActiveMQ and MuleSoft living alongside each other. We have multiple content management systems, some used more than others, and all of those ended up living inside of another one, really providing access to the right layer for our editors and writers. And that's our authentication and permissions application and API, logging, which handles revision control as well as access to content monitoring, our AI skills, which augment writing facilities for writers as they go through creating content, and social bots as well for posting to Twitter, LinkedIn, etc. We also had DAM, which handled Thumbore for images, Varnish for caching, and our DAM API. Also with the upside down smiley face is a legacy one, which I will not delve into everything that is in there. Spoilers are that it is a much longer list than the other ones. And then finally, admin or management, which Vadim talked about as well, where we store Jenkins Vault, monitoring tools, Jira, Confluence, and any other kind of utilities that allow us to deliver work or work towards delivering work in the day-to-day.
Well, and the reason the legacy is separate is that at some point we hope it's going to go away, and then this cluster just doesn't exist, right? So we're looking forward to that day in the future.
Yeah, it'll slowly be migrated out of existence. Yeah.
And one thing that we had to really focus on and was new to us in the cloud was security. In the data center, we were very comfortable with our security. We knew exactly how to handle it. Everything was firewalled nicely. So we had nothing to worry about at that point because we had so much experience with it. Starting to move to the cloud, we quickly realized that it's not going to be that simple. The reason is we move an application, HTTP access or HTTPS access is immediately available to the world, right? So we immediately started to pare the access down. We had to make sure that only applications that needed to talk to each other had that access. So our diagram we did in the beginning, our audit helped us a lot. We realized which applications had to talk to each other, and we would carefully only allow that level of access. We also obviously had to audit all the roles and who has access to dev project, to management project, to production project. We left that really small number of people to be able to access to production and management projects because most of our deployments and everything happens through the code. So in reality, unless you really have to, you don't need to have access to those projects by themselves. And I want to give a shout out to our security networking team. They've done an amazing job. They learned all of this and all these new tools really quickly. We could not have done it without them. They just jumped on it, they loved it, and they set it up really, really well. So really happy.
The same, and that's an amazing advantage that we really had during all of this too. I realized not every company actually has internal networking teams and internal security teams to provide assistance with that and to do auditing throughout. So having them spin up their skills in GCP and apply their pre-existing knowledge really just put us in a much more confident place throughout the whole process.
And learning new technologies like Istio, which we obviously didn't have, was critical for us, like kind of how easy it makes kind of our networking and splitting traffic and things like that was really amazing for us.
So let's talk a little bit about the refactor itself and what changed as we went from our data center into GCP. So what we originally thought, and this makes a tremendous amount of sense to me, hopefully it does to all of you as well, is we're going to evaluate if Google has a managed solution, right? They have something like Cloud Dataflow, Dataproc, like whatever. We're just going to use that. It'll be fantastic. We don't need to do anything, right? If they don't have one for it, though, that's fine too. We can move it as it is. We'll just throw it in a compute instance, and we'll refactor it later. The important thing for us, let's just get out of the data center. So after that, though, yeah, it seemed highly logical. I led with that. My bad. No. Yeah, so, but if we were going to containerize, we had already containerized something, why don't we orchestrate it, right? And once we have it orchestrated, well, now it makes sense for us to include a network mesh like Istio into the process too. And now that we have all three of those layers as well, and we have 50 services, what are we going to do? But we need to automate a way to not only like deploy those, but to move those from, you know, dev, staging, prod, do migrations, do network updatings, do patching. And then of course, like we can't write an individual pipeline for all 50 services, so we need to abstract it into something that can actually run across all of those. So while originally we were like, oh, we're just going to move them into the cloud and be done with it, very soon after we got through step one, we found ourselves going layer and layer of abstraction higher as we moved along with the migration. And I think one of the biggest things that kind of came out of that was a highly configurable master Jenkins build that does a lot of what I talked about before. It's highly parameterized, which actually means it requires a bit of training just to know how to build to it. You can hit last build too if you know the service. But this isn't just building something out like a new feature into production, non-production, into dev environments, which is automated, or moving that over to staging. This is really for like setting up our infrastructure and connections between new services as we move them between those different layers, or introduce a completely new application into our architecture overall.
So if you needed to set up a new cluster, set up node pools, set up networking, set up new DNS entries, everything can be done with a couple of settings and a click of a button. So this file actually is so crucial for us that moving from dev to stage, from stage to production, or introducing a new application on new cluster, or even upgrading the cluster, right, which happens a lot, was a breeze for us. Very, very important to automate, in my opinion.
Yeah, which landed us with our new stack. So, of course, we've already talked about Kubernetes quite a bit. We also have Google Cloud Storage, Istio, BigQuery, Helm. We have Cloud Functions currently just for billing alerts, but that's also very important, so please set those up if you're moving over. As well as ActiveMQ, MuleSoft, HashiCorp Vault for password and secret storage. MongoDB Atlas is our database for all environments, but we're now in Atlas, as well as Elastifile, which replaces our pre-existing head end.
And here's our new architecture diagram in cloud. It's very nicely structured and clear and clean, in my opinion. So we have one CDN Fastly in front of it, no F5 load balancing anymore. The clusters are divided as we discussed before. Our core cluster has varnish templates and API really close to each other, so there is no latency. We have the DAM, Digital Asset Management Cluster, which has Timbre for resizing, Varnish for caching, and DAM API, our homegrown solution. We also have our CMS, which is a single app application living in cloud storage. Those AI skills that we had in AWS, we migrated pretty easily to GCP, so they have kind of their own place there. Then ETL cluster is also separated. Again, our ActiveMQs and our MuleSoft. MongoDB in Atlas, huge help. Everything can be done on the fly there. Upgrades, indexes, whatever you need, so we don't have to worry about that. So hosted MongoDB solution.
And if you recall, we were MongoDB before the migration as well, but we moved over to Atlas versus hosting that ourselves as we were moving into the cloud.
Yeah, and they offer all three providers, cloud providers. Obviously, we're using Google. And one thing that we had to do for speed, we had to peer our applications, Google Cloud kind of project, to the actual Atlas project and Atlas Mongos. So that was very critical for us because we did see latency at first, and then after we did that, the speed was improved tremendously. Apache servers that we had in front of our NFS, also in Kubernetes now. And NFS, we did a lot of proof of concepts, and we moved it to Elastifile, kind of a hosted solution for that. So yeah, abstracted a little bit, but that's, in a nutshell, our new architecture in the cloud.
And one of the most powerful things from this as well is looking back to our old architecture, it was a lot of bespoke solutions, right? It was like how things had evolved over time and patched. And part of moving over to the cloud and that Jenkins build we talked about before was really taking a moment to see how we could reconfigure things and abstract them at another level, which also makes for, to be frank, a much prettier architecture diagram to present at conferences too.
Yeah, and obviously Kubernetes everywhere pretty much, and Istio for networking. So the learnings, what did we learn from our migration? One thing we quickly realized we have to monitor our costs. Set up alerts there, make sure that you really estimate well of what things gonna cost you, and make sure you have really rigorous alerts set up so you get notified if something happens. We learned really quickly in the beginning that we accidentally turned on debug logging on our Istio to go to Stackdriver, and our cost spiked, right? We luckily managed to catch it pretty quickly. If it didn't, I don't know how much it would have cost us, but after that we set up alerts really nicely, and now anything happens, we get a notification in Slack and by email that something is going up.
And watching those numbers tick up in semi-real time for the alerts was quite an experience as well until we turned that off. Yeah.
It's exciting. It's very different from being in a data center where everything is kind of static. Another struggle and challenge was taking a lot of new tech at once. So obviously, we had to learn a lot of new technologies, and we didn't want to leave a lot of technical debt. So kind of managing that of taking on a lot of new stuff like Istio, Helm that we had no experience before, and also doing things right was definitely something we had to manage. Team skills growth versus the timeline. Our timeline was pretty aggressive. And again, kind of making sure that the team was comfortable with new tech, was comfortable with supporting cloud, and our infrastructure in the cloud versus also pushing forward quickly, another challenge that we had. And doing a lot of different POCs. So one thing that we learned, and I think is a great thing to do, is fail quickly when you do proof of concepts and don't get attached. If something doesn't work, just move on and do another proof of concept, find the right solution for you.
A layer of abstraction added to that too was we actually introduced Helm earlier on in our process, but not at the very beginning. and it came onto our radar shortly after we started and already gotten some work done. And the same kind of applies to the inverse of proof of concepts, is if you've already started down one road and then you discover something, you're like, actually, this is just going to abstract it on a completely different level so we don't have to worry about it. Looking at the gains of making that switch versus doubling down on the road that you've already taken can actually save a tremendous amount of time and effort in the long run too.
Yeah, and the last point is balancing moving quickly manually and building automation was really critical for us. So obviously the urge is to move quickly. And what we started to do is started to just move things over with Kubernetes, but a lot of the things were set up manually, like clusters set up manually, upgrades were manual. A lot of builds were with Jenkins, but kind of setting up security, set up networking, DNS was done manually. And we would realize every time is like, when we do something, why don't we automate it? So we would take a step forward, take a couple of steps back, and we would do that a lot, actually, at least a few times for each. But I think it's worth it. I think if one thing that I had to change, I would try to build that foundation and build automation from the get-go. It's hard to know that in the beginning before you actually commit to something, because every time you do something, you're like, okay, we're doing it manually. Why don't we go back, automate it? And at the end, where we came to is we can do all of that with some configuration and a click of a button.
And you might feel like you're losing time by taking those back steps, but especially when we got into crunch towards the end of our timeline, and it just became choosing a couple options from drop-down menus in Jenkins versus having to do like actual work to move things along, it paid dividends.
Definitely would help you. We learned that pretty quickly. And now the benefits, right? Obviously, speed to market. What it helps us with our kind of process of deployment, the process of approvals with our stakeholders and product owners. Now we can easily, when we have a feature, create a box which we can send out to all our stakeholders or anybody in the company to take a look, approve it, and then we can push it to production. Obviously, it reduces manual work. Now our ops and DevOps team doesn't need to do manual patches. They don't have to go to the data center and, I don't know, do
restart
upgrades,
servers.
restart servers. None of that is needed to be handled by us now. That's all handled by Google, which we are very happy about. CI/CD pipelines, obviously much easier. Again, generated those boxes and environments on the fly for each application, for each feature, so they can be reviewed by stakeholders or QA, critical. Canary deployments, so basically pushing some percentage of the traffic to a new release, and then if it goes well, push it to 100%. If not, just scale down, destroy the bugs. That is really big for us for our kind of stability and scalability. And A/B testing. A/B testing is something that is crucial to our company. We base most of our major decisions, or pretty much all our decisions, on KPIs. So what we need to do, we need to A/B test every main feature that we release. And being in the cloud makes it much easier. We can spin up a new environment, point some traffic to it, then collect the data and see how it performs. And then scalability, right? If we need to process a lot of data, for example, at once, we can just scale up, and that's it. Before that, what we had to do is basically over-provision our servers and have huge machines in a data center that basically were ideal 90% of the time and only were needed maybe like, I don't know, a couple of days a year. So it was a waste, basically. Or just to prepare for some huge traffic spikes. Now it's all scalable and automated. And yeah, we just basically what we used to do is have huge boxes sitting there for no reason.
On the note of scalability too, part of that for us in our particular industry is also unpredictability, right? At Forbes, we really share the stories of people's success, and some of those people are very successful. So when they tweet about an article or something that's going on Forbes, that can generate a pretty tremendous spike in traffic going to particular pages or services. Another thing is we started to move faster and faster through all of this as well, was also being able to scale Jenkins, right, and getting that into K8s. And really what it was is once we started to have a proper pipeline with boxes built on every pull request for product owner approval, we hit bottlenecks very quickly when we were still in the data center. But moving that over and having that be abstracted a layer away just removed all those worries.
Yeah, but definitely one thing, make sure that all those boxes, they're not laying around, that you actually destroy them. So obviously set up some automation that bugs get basically killed every time you don't need it anymore. The way for us it works is basically when a developer creates a pull request, the dev bugs gets created, and when it's merged, it basically gets destroyed. So that way we manage it and don't just create
An
hundreds
infinite
of
number of instances.
environments, right?
Yeah. So soon to be integrated, or what we're really looking towards for the future, now that we're already in GCP and cut over, looking to expand that even more. So like I said, we're using Cloud Functions, but right now we're using them for billing alerts. There's definitely more potential there. There's definitely some things to be solved along the way in terms of code management, deployments, and how we actually handle that with our team and at scale, but increasingly so more and more. Cloud AutoML, machine learning and AI is major to Forbes as it is to a tremendous amount of companies right now. For us, it particularly ties into editorial assistance and how we work with our writers, though it definitely bleeds into a number of other parts of our organization as well.
It's the skills that we showed you basically. And a lot of them are based on using some of these Google technologies that are amazing. And we're really happy to have those APIs available to us so we don't have to actually write our own NLP or sentiment analysis and things like that. So we're using that a lot. But as new ones get kind of created all the time, we would like to expand as much as possible.
For sure. And adding that layer of abstraction helps our team move with increased velocity as well. So Cloud Data Flow, actually a similar vein for our ETL pipelines, and looking to see how that might be able to abstract some of the more manual work that we do right now. Manual being manual coding, not humans doing work. Cloud PubSub, dissimilar but abstracted effect. And I think the real next step for us is now that we have this whole architecture migrated over to Google Cloud, is setting it up with Terraform so that not only can we set up and build new applications, new instances, and migrate those between dev staging and production, but so we can set up an entirely new ecosystem on the fly as we need to.
And we already started on that. And right now, as we kind of discussed and mentioned, we can create application cluster, anything in that environment, but we want to be able to, with one push of a button, to generate everything right away or anywhere, right? So this is going to be a huge step for us in the future, and I think that's pretty much the next step for us.
Yeah, which is well underway.
Yeah.